Hello everyone. Welcome to another learning session. This session is part of a series about how to launch a parachain with the aim to guide you through the whole process from ground zero to making and managing your live parachain. So last time we have talked about what are the advantages of becoming a parachain on Polkadot, provided a roadmap around the different decisions when launching a parachain, covered the options to deploy on Polkadot, talked about deploying and winning an auction. And last but not least, we had a full demo of onboarding a parachain on a local testnet. The title of this episode is From Launch to Interoperability. And we are going to cover some recommendations and best practices around DevOps and building a team, extending a parachain slot and swap leases. We will talk about collator selection, options to manage a parachain from the relay chain, and to conclude, we will explain and demo HRMP channels between parachains for interoperability. So without further ado, let's dive into it. So let's start with the team behind the parachain. Last time we have covered the multidimensional nature of launching a successful parachain project where product development, funding, marketing, and team building are all need to happen parallelly. Building and launching a product in this space can be different from traditional product launches. One thing is sure, a wide variety of skills are needed to make it successful. With a fast-changing technology stack, finding and keeping talents in this industry can be difficult. We have collected a few recommendations on building a team to build a parachain. Although many skills are needed, luckily it is not necessary to have a full-time employee for every role. In startups, the first employees often wear many different hats. It is possible to cover many bases with just a few versatile people responsible for several different areas. It is also possible to hire talents for dedicated areas only, or only part-time, or on a need basis. When choosing a candidate, first of all, it is important to find the specific skills needed for that particular position. Consider how each hire will fit into the team, how their skills can complement the skills of the team, and how well they can communicate and cooperate with existing team members. It is also important to consider the situation each new hire will be in, both in the short term and in the long term. For example, hiring the first developer, you may need someone who can work alone, have more relevant experience. Of course, this means the candidate will probably have a higher salary expectation as well. Building a team will have a different focus in different stages of the development process. So in the early stages, focus should be, of course, on technical development. After the first proof of concept, it is usually time to expand, maybe hire more core engineers, front-end developers, or even designers. This can be very different for each project, based on their product and situation. Complexity may increase quite rapidly, so having 5+ people in the tech team, it is worth considering adding a project manager to the team. Another important role of early parachain projects is a community manager. A good community manager can kickstart your community and provide more and more value to the project. In case you are creating a crowd loan, your community is essential to winning a parachain slot. Engaging your community and creating events is a good way to attract some talents who are already excited about your project. In fact, many projects put a big emphasis on finding candidates that are part of their community and are really interested in its mission. This is important because developing a new product can be quite challenging and requires employees that are willing to persevere. Early legal advice can be essential, so it is recommended to find someone who can support the project in this area, even if it's not a full-time role. This could be very helpful to navigate the legal aspects of hiring people and building a product. Both security and DevOps roles are fundamental, and having someone to cover these areas relatively early can be quite rewarding as well. It enables to lay the foundations and introduce basic security and DevOps best practices. After the parachain has connected to the relay chain, the focus on the technical aspects and DevOps continues to be a top priority, but growing the team and the business will be as much important. So as a team grows, operations and admin roles are more and more necessary to manage the organization and improve overall efficiency. As hiring plays an important part in this stage, an experienced recruiter can save a lot of time and money for a project. As there is great competition on the market for good talent, for example, in substrate engineer role, it is important to research the market to be aware of the salary trends and what talents you can expect for the money you are willing to offer. Sometimes it can be better to lower expectations and invest in training than to wait for a perfect candidate with a low salary expectation. So in this stage, another big focus area is business development, covering growth and partnerships with ecosystem players. It could be essential to integrate with key tools like wallets and be listed on exchanges. In the later stages, of course, you still need a developer and DevOps team, but the focus may shift from developing to maintaining. In this stage, it is important to think about developer relations and documentation as well. A technical writer can make sure all docs are in order, and the developer relations advocate can focus on building a developer community around the project. This is the time to build out the marketing team as well, to build a brand and ensure you are visible and present at important events. Hiring a remote workforce increases the pool of candidates, but it may be better for specific teams, for example, the developer team, to be at least in similar time zone. This ensures efficient cooperation compared to waiting for a response from someone on the other side of the world. Also, when hiring from another country, projects must be aware of any legal restrictions and tax implications of the candidate's country of residence. So it is best to be proactive with hiring and plan ahead, as it can take several months for a new hire to really add value. This is especially true in case outside training is involved. For example, the Polkadot Blockchain Academy, which is scheduled only twice per year currently. So these are just general guidelines and recommendations, but of course, it all depends on the case, and each team has to decide and plan based on their specific situation. So going to the next slide. So blockchain is more than computer code. It is a combination of both hardware and software. To be successful as a parachain, it is very important to have a sustainable infrastructure. So as a general rule, it is better to invest in making this right and scalable at the first time. Trying to fix things after the fact can be much more difficult and time-consuming. So let's go through a few of the DevOps best practices that can help you in building and maintaining your parachain. So first point is security. For blockchain, security is a fundamental consideration. And general good practice is using proxy account to limit permission that an account has on another account. And the use of multi-sig accounts is also recommended. On the infrastructure side, it is very important to have strict rules and block any non-required communication. Monitoring logs and using two-factor authentication is also advised. Regarding updates, another basic principle is to ensure that all your systems are kept up to date. This is critical regarding security updates. It's best to check for the security updates daily, especially when running public-facing services. And if possible, try to automate the process as well. So, and also make sure you can easily bootstrap a new system from scratch if needed. Try to avoid manual configuration of these systems and treat infrastructure as code. You can use configuration management systems like Ansible to configure and automate servers in a DevOps environment. There are other tools available in the market as well, like, for example, Puppet and Chef. If a service crashes for some reason, make sure it restarts automatically. Also make sure that the automatic restart doesn't happen without anyone taking notice, or else you can have an issue you are unaware, and that can potentially lead to more serious problems. You need to have some kind of monitoring set up to increase observability of the components and also to detect any anomaly. You can use tools like Grafana and Prometheus two open source tools for monitoring applications. It is also important to have some kind of alerting in place. The alerts should be actionable. There is no point in creating alerts for everything. Reduce the noise and keep alerts only for the most important things. And during the development, test new binaries periodically on a testnet as well, because issues may only appear in real-life conditions, in real networks, having network latency, memory leaks, etc. Also, for teams experienced with Kubernetes, Parity provides two tools to make the management of substrate-based nodes easy. First one is the Parity Helm chart, which is a Helm chart to deploy all types of nodes. The second one is the testnet manager, which is a powerful tool for deploying and maintaining test networks. So please find further details about these tools and the DevOps best practices on the Parity GitHub, and you can use this to decode as well to get there. So after the Parachain has launched and is running, it's time to think about the transition from sudo to governance. But what is sudo? So sudo is a program for Unix-like computer operating systems that allows users to run programs with the security privileges of another user, the super user by default. So having the sudo palette in your runtime enables you to elevate privileges like a super user. So with sudo, you can execute privileged functions, functions that specifically require the root origin. So why use sudo in the first place? Most parachains start up with sudo as it makes the process easier. It allows to bypass any governance in cases when a root origin is required. It enables the team to see balances or do other administrative tasks easier and faster. Sudo is recommended to include in a new parachain until some on-chain governance system has been tested and proven. So why not keep sudo forever? Sudo centralizes all power in a single account. And that account is able to do things even if the token holders don't agree or if it's detrimental to the community. So users who are looking for decentralization will not choose a centralized network over another where all token holders have a voice. So most parachains may start with sudo, but quickly switch to some form of governance to execute higher privileged functions. In fact, Polkadot also started with sudo, and one of the main stages of becoming a truly decentralized network was the implementation of governance, and it then used that same governance to decide and execute the removal of sudo itself. So what are the options instead of sudo? There are several palettes already available within Substrate, and you can use or start from these to compose your own custom system of governance. These are palettes such as democracy, collective, membership, conviction voting, and a number of others. But you can also implement your own custom logic by creating new palettes to meet your specific needs. So about auction. It is not enough to win an auction once. You need to have a plan how to keep your slot. So at the end of the Parachain slot list, the slot will go for a new auction, and the team will need to bid for a slot again. Parachain slots are fungible, so parachains do not need to bid for the same slot, just need to make sure that they have one. When extending a lease, scheduling could be even more important because losing the auction may result in downtime. Planning for a lease extension, it is important to understand lease periods. So lease periods are 6 or 12-week long periods that make up the lease duration of the slot. Each slot consists of 8 consecutive lease periods. Bidders can submit a configuration of bids specifying the token amount they are willing to bond and for which periods. Any number of lease periods can be included. Multiple different bids can be submitted by the same bidders, but only one bid or a combination of non-overlapping bids will win. The winner selection algorithm will choose the bids to have the maximum amount of tokens bonded over the entire period. So it's important to note that the end of this slot has nothing to do with the date of the auction for that slot, but depends on the exact lease periods the auction was about. So see example of parachain A and B winning different auctions, but leasing their slot for the exact same period. By parachain C and D winning their auction right after, but having different lease periods. In fact, there can be several auctions on different weeks or in different months that will let you bid for the exact same lease periods. And this means that when a particular lease period is ending, several winners of previous auctions will be in the same situation and potentially be competing for an extension at the same time. And not counting with the new teams going for their first parachain slot. So parachain teams have to take this into consideration and plan their extension accordingly to ensure the continuity of their parachain slot. Typically, parachain candidates bid for the entire lease duration, which is all 8 lease periods. But in the future, different teams may opt for only 1 or 2 LPs in the duration in order to secure more and more additional lease periods as soon as possible. So see example of parachain A, not waiting for the last minute, but winning a bid for lease period 9 and 10 in auction 6, extending its lease just a few months after securing lease periods 1 to 8. So to extend the lease of your parachain, there are several options. Lease extension with overlapping slot is one of them. So slot overlapping occurs when parachain acquire a new slot where the first lease period of this new slot is before the last lease period of the current slot. So for the duration of the overlap, the team has actually more than one slot available for them. So what are the pros and cons of this? First of all, the parachain can make sure that a new slot is secured long before their current slot ends, continuing their current lease without any interruption. So the slot can be swapped anytime in the overlapping period through, for example, an axial message to the relay chain. What are the cons? So this swap also requires 2 live parachains to send the message. So the parachain team needs to start another parachain with a new para ID on the new slot to be able to send the message and swap the slot. So the new parachain may have very basic functionalities. Still, it has to be created in order for this to work. Also worth noting that in case the parachain won a slot through a crowd loan, it is not possible to extend that slot through another crowd loan with the same para ID overlapping the current slot. So this extension with non-overlapping slot is another option. And this happens when the first lease period of the new slot starts right after the end of the last lease period of the current slot. So what are the pros? The parachain can extend the lease using the current para ID. The lease will be automatically extended. There is no need for swapping. Also, there are no superfluous lease periods because there are no overlaps, which is more efficient. So what are the cons? There is no flexibility when the parachain can win the new slot. If the team does not win that single slot, then most likely it will suffer some downtime until they can win another. So the introduction of parathreads or different core scheduling options will likely help parachains that fail to secure an extension, as they will be able to pay on a per block basis. So yeah, that's from my side. And with this, I'm going to pass over to Alejandro.
Nice. So thank you very much, Daniel. Um, I would like to start mentioning, double clicking on something that Danny mentioned, which is like what happens when like there is the possibility of like somebody, some entity, some account, like on the management party, like management side, like being able to like do certain actions like without the need of a consensus from the community or something like that, right? I'm not specifically talking about governance, but it's just like a subtle thing, right? Which is the account that registers like the parachain in the relay chain, which this basically implies like submitting the code, like the validation function and the state. Um, it's considered like the manager account for that parachain, right? And this manager account like can do like certain actions depending on if the parachain is logged or not. This logged status like arrives or like it's set like in different scenarios, right? Like the scenarios are the two that are there in the slide. But basically, when a parachain like opens, creates a crowdloan campaign for itself to fund itself to be able to bid for for a certain like slot for certain like list periods, then the configuration of this parachain, like this like validation function on this state head, will get logged. The parachain ID will get like a manager log. So like the backers, the users of this like crowdloan campaign, can be sure that the committed state and function by the parachain team will be the same once this crowdloan campaign is finished. It will not change. So they will not be changed for something like malicious at the very end or like that will be like bad for the backers, right? So there's like this kind of like contract between the backers and like the team, which is represented with this log that doesn't allow the manager just by its own like changing like certain um, aspects of the parachain as they can be like the state which it starts from or like the validation function. So the other scenario where we find like this log happening is when a para thread like onboards as a parachain, so the life cycle for the parachain like changes from parachain to parachain, then it gets the log in there. And from there on, like there are like if the validation function needs to be changed, then there's like runtime upgrades and so on, right? Okay, this is important, and I wanted to mention it. And with this information, let's jump to the next slide, which is like managing a managing a parachain, right? I have like call it like this, but in fact, what I want to mention here is like, okay, from the relay chain side, which options, like which extrinsics even like do we have in order to like make some changes in our parachain or like do certain actions with it. I wanted to focus precisely on the paras registrar palette that is written in there, which exposes like the four extrinsics that are on the screen. Like these four extrinsics will check that the origin, the signee, is either the parachain itself, the manager, or root. In case of being the manager, of course, like the state of the parachain like needs to be unlocked. If not, the parachain will not be allowed to do these actions. And that's the only case where the lock is checked. But then, like, if the para is the origin or root, then like these actions will be permitted. Just going quickly over them, the register will free all the relevant information for this parachain. Will be like all the stored information in the relay chain for this parachain, and then like we'll continue like freeing and giving back any deposit related to this part. Swap. You notice that a certain parachain is willing to swap leases and crowdloan information with another parachain. And schedule code upgrade. It's an extrinsic that let us like program or schedule. I don't want to repeat the schedule, but like a new validation function from a certain block. And very same with set current head that will allow us to change the head, the state that we will be building from for this parity on the relay. So these four very useful. They will be used like in different moments of the life cycle of the parachain. For example, the last two code upgrade on the subcurrent head are very useful if we are troubleshooting something. We need to do these actions. We find ourselves in a scenario where they cannot be like triggered from the parachain side, and we need to like to take action directly on the relay chain side, right? Maybe we need like to open a motion. Maybe we need to do like 13 like different paths to arrive here, but this possibilities exist and they are there to help managing the purchase. So next thing, I would love to stop here, make a quick mention to like how one should select collectors. I don't know if should is the right word, but selecting collectors in general, right? There is like two approaches, more or less. I'm mentioning here two approaches, which I will be like um, covering like collectors selection, which is a palette that sits within Cumulus, and then like any other like collector stake in implementation, right? These two will be like mainly used when this parting team like wants to open their collector set to the community and wants to like onboard like other collectors, other people to run collectors for them, um, rather than the ones that have been set up on the chain spec or in the vulnerable state, right? So collector selection, as I was mentioning, sits with Cumulus, and this palette will build like the collector set from the invulnerables collectors and some candidates, right? The invulnerables are set either by the governance or yeah, by governance or root, and the candidates are any public entity that wants to join will bond like some amount of tokens, and they will like be able to be part of this pool. Then, uh, based on like certain parameters, like a set of collectors will be created, and the authors of the blocks will be rewarded, right, for doing that job. This is like kind of the very straightforward approach, which makes this very simple. Uh, Makes the action of like okay, adding collectors once the chain is running like pretty like simple, but there's like more quote unquote complex or like interesting approaches that as they could be some sort of like staking mechanisms to choose like this collector set, right? Here in the slides I mentioned like the implementation that Moonbeam Parachain team did, which basically like chooses these collectors based on the the stake that is baking them, and it's like a direct like baking system, right? So with this kind of systems, you can like include like way more incentivation around how to choose like collectors, and as well like a little bit of maybe gamification because like well if maybe you want like the users of your project to nominate who is a collector, and by some those nominations you can do something, right? Also like it gives you like room to include this into the tokenomics of your of of, of your part, right? Whatever you might be like thinking about. And I cannot like pass to the next slide without mentioning that collation and this collector said, like, and maybe this is taken about collation is not a security activity, which means that in instance, for example, as a content path, like the staking going on the relay chain, like all the validators in there are doing like a security activity. They are securing the network in different ways, economically and like by getting like this distributed validator set. But on the collector's part, that's not happening. Like all the security is leveraged from Polkadot security from the relay chain one, and mostly like the best thing that you get out of this like collector set will be like better availability if the collector is distributed, and getting like some nodes running in run by the community, which is always like really nice. And it's always a step into like the decentralization and distribution of the nodes, right? Which is like pretty cool. So with this mention, I would like to do like a very quick demo on swapping leases between parachains. Let's just jump right into it. I have running locally related with a few parachains. I have used like ZombieNet to bootstrap the whole network, and this will be like the result. Okay, Rococo local runtime and two parachains here, parachain 1000, parachain 2000. All the way to the right, we can see like the list information. Maybe I can zoom in 2 times, so it might be like a little bit bigger and easier to read. We can see, for example, Parachain 1000 has like 10 lists assigned from list 0 to list 9, and Parachain 2000 has way more, from has 100 basically, right? Okay, what will happen when list period 9 finishes? So when list period 9 finishes, Parachain 1000 will downgrade, will not be a parachain anymore, so we won't be producing blocks anymore. Usually that's not what you want, and when that moment is approaching, the team might consider, okay, we might need to swap our leases with another parachain that has more leases in order to keep on like being a parachain and keep on producing blocks. So how do we do this, right? I mentioned in the previous slide, registrar palette like exposes an extrinsic, which is swap extrinsic, which notice like this wheel of changing this information, right, from one parachain to another. Okay, we could do this like in this demo, during this demo, for the sake of time. I'm going to be like using sudo, but obviously this is not always an option. Most likely what you will find in ecosystems like Polkadot will be like governance proposals, or if you could like send an upward message written with XCM, like composed with XCM, that will execute this this call in the relay chain, right? Like this is a call that you want to execute eventually on the relay chain side. If you send it like through XCM, sorry, the good thing is like the origin will be like the parachain, ideally. So like this call, like for swap, will check if the origin is the para. If in case it's the para, everything is correct and can continue, right? On the route governance, sudo if it does exist, where the environment you're working with, but eventually like you will end up like with the following result, right? Also, like this has to happen like in both ways. So usually what you will find, it will be like a batch call with both of the extrinsics being asked for execution, right? Like of them. So you will find like the swap from 1000 to 2000 and the other way around. All right. In this demo, I'm not going to execute this. I want to do it like in 2 steps because I want you to see something, right? Let's execute the swap that we have here. Okay, and let's check the state now. Register palette also like what exposes like this pending swap storage entry, which if we check for the parachain ID 1000, that is what we have executed, we can see that now we have a pending swap with parachain 2000. In case the parachain 2000 decides to swap again, to do the swap as well, the swap will happen. So let's execute it the other way around. Let's do 2000 to 1000. Everything was good. We can check that the value for this key has disappeared, has been cleaned after the swap was made. And if we go back, we can see that the parachain 1000 now is holding like the 100 list periods, and parachain 2000 has only like 10. This is not the only information that will be swapped, as I mentioned. Like the crawl on the funds information are also like swap, are also changed from one parachain to another, right? We could see like this in the code. This is the runtime configuration for Kusama. And here, like we can see that on swap is configured to call crawlons and slots. This two implementations. Here we can see like on-swap trade implementation for the slots, and we will see that is the leases storage information, which is mutated between the two varieties, and we can see like a very similar implementation for the crowd loans, and then in this case is funds, which will be mutated. All right. Very useful option, which has already like been like leveraged by the community a lot. And this is an area that what we have like showcased here will be like when there are like two parachains that are running and their lease periods overlap. Okay, swaps can happen between a parachain and a parathread as well. That's something that works. That's something that it could be done. Like the parathread will change life cycles as well as the parachain on the other side, and the information will swap just in the same. This is everything from my side, and now I will leave it to Nacho, that will be like commenting a little bit on interoperability and HRMP channels. So all yours, Nacho.
Hello, everybody. Thank you, Alejandro. Let's talk about interoperability. Okay, so by default, Parachain, when they go live, they are isolated between each other. They only have communication with the relay chain through XCM. But there are like a couple of mechanisms to open channels to make it happen. So the first one is HRMP, which is the one that is currently working in Polkadot and Kusama. And the downside of this approach is the demanding in terms of resources, because the two parachains are using the relay chain as way of communicating using data storage. So you know that each parachain collator, the parachain collators have like a full node of the relay chain, so they are able to read the storage from the relay chain. So if you want to communicate with another parachain, what for example a parachain A would do is to send XCM message to the relay chain. The relay chain will process the XCM message, store the message in their storage, and then a collator from parachain B will read the state from the relay chain and pick up that message. The other mechanism would be XCME. This will be actually, because it's not yet implemented, but it will happen in the future. It's a direct communication one-to-one between parachains bypassing the relay chain. So HRMP channels are actually unidirectional. So if you want a full bidirectional communication between two parachains, what you need to do is to open two HRMP channels, one from parachain A to parachain B, and from parachain B to parachain A. Let's talk about configuration. So there are especially two parameters you have to pay attention to. These parameters are proposed max capacity and proposed max message size. The first one is the maximum number of messages allowed in the HRMP channel at once, and the second one is the maximum total size of messages in bytes allowed in HRMP channel at once. So you cannot like set like arbitrary value for these parameters, because they are constrained by the relay chain configuration. So if you go to query the storage of the relay chain, you go to configuration, active configuration, you can get HRMP channel max capacity and HRMP channel max message size. So basically, those are the limits. So your proposed value should always be like smaller or lower than the relay chain configuration. So for opening channels, it's like a two-phase process. So one of the actors, one parachain, has to initiate the opening channeling flow by requesting opening the channel to another parachain. And then only when a parachain B accepts that request is when the HRMP channel is established. Notice that these actions are not free, as many or like most of actions that you do in Polkadot. So you'll need to have the sovereign accounts of these parachains will need to have a couple of deposits, so enough free balance. You can check what's the value for your relay chain for Kusama or Polkadot. Those are the HRMP sender deposits and HRMP recipient deposit. There are two opening types. It will depend on the parachains involved. If you have one system parachain trying to connect to a community parachain, then the process goes through the relay chain governance. That is because system parachains are controlled by the relay chain governance. However, if you have two parachains, they can open HRMP channels whenever they want, and they can agree on the characteristics of this HRMP channel. So, sorry, a second. So in this case, the channel will be open and initiated by each parachain through XML message to the relay chain. System para to para. Okay, let's take a look at the first option. So there are also two ways of opening channels. It will depend on the governance type. Okay, so if we are in Kusama, where if we are in Polkadot, where we still have the old governance version 1, the process will start with a council motion that will become like a democracy referendum to be finally enacted. On the other hand, if you are in Kusama, where there is already the new governance version 2 OpenGov, we have two different tracks that can happen at the same time. In one side, you have the whitelisted color track with a referendum with the pre-image, which is the pre-image is the action. The pre-image is like the call, the pre-image of the call that will open the HRM channels. And in the other side, you have a fellowship referendum. What's the goal of this fellowship referendum? So the goal is to whitelist the call, the image that is coming from the whitelisted caller. This is done to upgrade the origin of the track from whitelisted to root. Okay. So as soon as when the referendum, the whitelisted caller referendum finishes, as soon as the fellowship referendum has finished and whitelisted the pre-image, it will succeed. In both cases, since it has to go through governance in the relay chain, participants or like parachains that want to open channels will have to, or it's like a good practice to open a discussion either in Polka Sembril or Subsquare to tell the community their intention to open a channel with a system parachain. Let's take a closer look to how the system to parachain message looks like. Okay, the one that will go through governance. So we have to notice that there is a dependency. Remember that you have to pay for these actions. You need to have a deposit. So we want to make sure that the system parachain and the parachain sovereign accounts have enough balance for the HRMP sender deposit and the HRMP recipient deposit. So this would be the call. Okay, first of all, we have a force batch. So a force batch will execute each of the calls inside of the batch, but if one of them fails, it will continue. Okay, and each of the calls is at the same time a batch all. So the difference between force batch and batch all is like in batch all, if only one of the calls inside fails, the whole batch will fail. So this allows the governance to bundle many requests in a single batch. So for example, imagine that this first one is like, for example, a pin channel between, I don't know, like a state bean and moonbeam. And for some reason it fails, but it goes to the next batch with opening like channel between Akala and statement, and it can succeed. And closer look to the parachain to parachain message. So remember, this is like a two-phase process. So same thing. Both parachains need to have enough balance for the deposit, but they also need to have like an extra balance to pay for the XCM execution in the relay chain. So if you remember, it's done from with XCM messages from each parachain. So in parachain A, we'll start we'll initiate the request for opening a channel, and the parachain B will accept the request. So remember that if we want the bidirectional communication, this process will have to happen in the other way around. If we take a look at the message, it's like a Polkadot XCM send, where the destination is parent one, which is the relay chain, and then we have XCM message with 4 instructions. The first one is withdraw asset, to withdraw, to be able to pay for execution, then to buy execution, then transact. So this is the transaction, the call that will be executed in the relay chain. And finally, deposit asset. This instruction is very important to be added, because if you don't add this final instruction, the unspent fees for executing this XCM message will be trapped. Let's talk about a little bit about the importance of integration test tools. When you are isolated, unit tests or like unit tests in your palettes are usually enough. But when you have to interact with other runtimes, you need to have other tools, okay, for integration test. There are many options. So the first one is XCM Simulator. You can find it under the Polkadot repository. Then you have Chopsticks, that it's developed by Akala. Then you have ZombieNet test, that it's you can write test in ZombieNet also. And then you have Parachain integration test, which is like a extra layer of abstraction on top of ZombieNet that will help you to write this rapidly, and it's like an abstraction from the Polkadot.js API package. Okay, let's do a quick demo for HRMP channel, and we'll use one of these integration test tool. Okay, so I have here infra, okay, with a relay chain, Polkadot. Here we have a statement and a couple of parachains, okay? Penpal parachain 2000 and 2001. Here with the parachain integration test, I can spawn the infrastructure. And here we have the config file. Okay, as I said, we have Polkadot, statement, Penpal 2000, and Penpal 2001. You should know that for using Polkadot with sudo and also with shorter like epoch times, you should use one of these special branches that are used for integration tests with sudo on it. So also you will have to compile these branches with the feature fast runtime, okay, to reduce the epoch times, among other variables. This is important to bypass governance using sudo. Okay, so let's take a look at the first case. From the system parachain to a parachain. See here, we need like a deposit for the sender, for the recipient. And then here, the dependency. Okay, so we have to fund the sovereign account of the parachain in the relay chain. And here is how we open the channel. So this, in this case, this would go through governance. Here we have the first batch, and then here we will have like a batch all for each channel. Okay, so here you can see how we found the system parachain, then we force a streaming channel from system to para, and the same from para to system. Let's run it. And here we can see, yeah. Here we have the first batch. Okay, in this case we had to use sudo because we don't have the root origin, because it's not coming from democracy palette. Okay, but you have here the two force open streaming channels, one from system parachain to 2000 and the other way around. Okay, and now let's take a look at the second case. Here, notice as we need like an extra fees for paying the XCN message. This is the dependency, so we have to fund both Parachain A and Parachain B sovereign accounts. This would be the first call, okay, from Parachain A to Parachain B, where we are requesting opening a channel with the withdraw, by execution, transact, and deposit. Here we have it. So HRMP init open channel. And this is the second call from the Parachain B to Parachain A, where it's like accept the request. HRMP accept open channel. So let's run it. So while it's running, let's take a look at some of the concepts we talked about before. So we are in the relay chain. If we go to the chain state, you can go to configuration, active configuration. Yeah, and here you can see different values. For example, the sender deposit, because this is a testnet, the deposit is set to 0. Here you have the max capacity and the max total size. Okay, it's still running. Also here we can take the encoded call. This is another way of taking a look at what's happening. So this is Parachain A, I think. This is the XCN message. We can go to extrinsics, the code. Yep. And here we have the pseudo call with the Polkadot XCN message. In this case, we are using XCN version 3 with the withdraw, by execution, transact, and deposit. Okay, so everybody, sorry, everything went well. If we take a look at the events, we see how the message has been like executed properly. And then here at some point, if you go to the HRMP channel, here, yeah, we see here all the channels open. The system parachain to 2000, and then the channels between Parachain A and Parachain B. So yeah, thank you everybody. I hope you enjoyed it.